All right. So before we jump in, I always like to remind our listeners to go back and listen to the theme song.
Yeah.
There might be a few things in there that you didn't pick up on the first time, so give it a listen. But today we're going to be talking about logistic regression.
Mm-hmm.
And, I think we can assume that our listeners are pretty familiar with concepts like, cross-entropy and gradient descent.
Yeah, we've covered that before.
We have, so we're going to be able to jump right into the good stuff.
Right to the meat.
Right to the meat. So
logistic regression is a really great algorithm for classification problems.
Yeah.
So rather than predicting like a particular number, it's going to predict like a category.
Yeah.
So like, is this email spam or not spam?
Right.
Is this tumor cancerous or not cancerous?
It's like that.
Things like that, exactly. So let's take an example of trying to predict whether a tumor is cancerous or not. And so we're going to use this thing called the sigmoid function.
Okay.
And the sigmoid function basically takes in a bunch of inputs.
Okay.
And spits out a probability between 0 and 1.
Okay.
So it's like...
So the closer it is to 1, the more likely it is that that tumor is cancerous.
Yeah. The closer to 1, the higher the probability that the event's going to happen.
Gotcha.
So let's say our model spits out a probability of 0.2 for cancer.
Okay.
And 0.8 for no cancer.
Okay.
But in reality, the tumor turns out to be benign.
Right.
So how do we figure out like how off our prediction was?
Well, I would think that you would look at, so it was 0.2% chance of it being cancerous, and it wasn't.
Right.
So
you're on the right track.
Okay.
But we need a way to like quantify like how off we were.
Right.
And that's where cross entropy comes in.
Gotcha.
So cross entropy basically gives us a measure of how surprised our model is by the actual outcome.
Right. So like the higher the surprise, the worse the model. Okay.
Exactly.
Yeah.
And so I can quickly walk you through the calculation.
Okay.
It's basically the true probability, which is 1 for no cancer.
Right.
And then the model predicted 0.8 for no cancer.
Okay.
So if you plug that into the cross entropy formula, you get an error of about 0.22.
Okay. So an error of 0.22, like what does that really tell us?
So that basically tells us how far off our model's prediction was from the actual truth. And so the lower this cross entropy error, the better our model is at classifying those tumors.
Got it. So it's all about, minimizing that error.
Right.
But how does logistic regression do that?
Yeah. So at the heart of it all is this sigmoid function we were talking about before.
Right.
So think of it as like a translator that converts our model's raw output into a probability that makes sense for our classification problem.
Okay.
Right. So we're feeding in all these features about the tumor to the sigmoid function.
Okay.
And it's spitting out a probability score.
Okay.
This function isn't just like arbitrarily chosen.
Right.
It's mathematically designed to be smooth and predictable.
Okay.
Which is really important.
Okay.
For the next step, which is finding the best parameters or weights for our model.
Right.
And this is where gradient descent comes in.
Gradient descent. Yeah. Like what we were talking about before, it's like, how do we, find the best weights for our model?
Yeah. You can think of gradient descent as like navigating a mountainous terrain.
Okay.
And our goal is to find like the lowest point in that terrain where the error is the smallest.
Gotcha.
And we do this by taking small steps downhill.
Okay.
And the direction of each step is determined by the gradient.
So the gradient's kind of like a compass that tells us which way to go.
Yeah, that's a great analogy.
To get to the best solution.
And remember, all of this relies on the fact that we have a way to measure how off our predictions are.
Right.
Which is what cross entropy provides.
Right.
So it's like a feedback mechanism that tells us how well we're doing.
Gotcha.
And guides us towards better prediction.
Okay, cool. So we've got our sigmoid function, which is kind of translating the raw data into a probability.
Exactly.
And then we're using cross entropy to kind of see how surprised we are.
Yep.
By how well the model's working.
Yeah.
And then we're using gradient descent to figure out, how to adjust the weights.
Exactly.
Okay.
It all works together.
Awesome.
Yeah. So
pretty neat.
Pretty neat.
Yeah. Yeah. And then you can repeat that process over and over again with tons of data.
Right.
And eventually end up with a model that's
pretty accurate.
Yeah.
Yeah. Pretty accurate.
It's very cool how all these different things work together.
It is, but even though it seems complicated at first,
The core idea is actually pretty simple. It's like we're just trying to fit a line to our data so that we can separate those two categories as accurately as possible.
So it's like drawing a line in the sand.
Exactly.
And on one side of the line's cancerous and on the other side it's not?
Yeah, that's a great way to visualize it.
Okay.
Now, in the real world, it's not always that clean.
Yeah.
Like, there's always going to be some overlap and uncertainty.
Right.
But that's where the sigmoid function comes in.
Right, because it's giving us a probability instead of like a hard yes or no.
Exactly, and that's one of the things that makes logistic regression so powerful.
Right.
Is that it can handle these messy real-world situations where it's not always perfectly clear.
Right, so that kind of brings us back to, what we were talking about before about making sure that we're selecting the right features for our model.
Absolutely.
Feature selection is critical.
Garbage in, garbage out.
Exactly. We want to choose features that are actually informative and relevant to the problem we're trying to solve, not just throw the whole kitchen sink at it.
Exactly. And this is where domain expertise can come in handy.
Right.
So if we understand the problem really well, we can make better decisions about what features are going to be helpful.
Okay. I'm starting to get the bigger picture here.
Yeah.
But are there any limitations to logistic regression? Like, when would it not be the best tool?
Yeah. So one thing to keep in mind is that logistic regression works best when the relationship between our features and our target variable is relatively linear.
So if it's more of a curvy relationship.
Yeah, then we might need to look at some other algorithms.
Okay.
But for a lot of classification problems,
right,
especially binary outcomes,
right,
logistic regression is a great place to start.
Okay. And it really all comes back to understanding, those basic concepts.
Exactly.
The sigmoid function, the cross entropy, and the gradient descent.
Yeah.
Once you kind of understand those three things, you can unlock a lot of different machine learning.
Yeah, you've got a good foundation.
Yeah.
For understanding. Yeah.
A lot of machine learning techniques.
So, before we wrap up,
I
just want to remind everyone again about, that theme song.
Oh, yeah.
If you're looking for a little extra knowledge,
you might want to check it out.
It might be in there.
You never know what you might learn.
Who knows? There could be some secrets in there.
Yeah, sometimes the most unexpected places can offer some surprising knowledge.
Right. It's like a little,
Easter egg hunt for knowledge seekers.
Yeah, exactly. But, okay, let's get back to logistic regression.
Okay, yeah. So we were talking about how these key concepts like the sigmoid function, cross entropy, and gradient descent all kind of work together.
Right.
To guide us towards the best possible model.
It's really cool how, like, these really complex mathematical ideas end up, being solutions to real-world problems.
It is, isn't it? And what's really remarkable is how widely applicable these concepts are.
Yeah. So, once you understand them in the context of logistic regression, you'll start to see them pop up in other machine learning algorithms as well.
Yeah, it's like unlocking a secret code that lets you understand everything.
Exactly. It's like learning a new language that allows you to communicate with data and extract meaningful insights.
That's a great way to put it.
Yeah.
So, we've talked about logistic regression and, all the things that go into it. What's something that you find really interesting about logistic regression?
Well, what I find really fascinating about logistic regression is how elegant and efficient it is.
Okay.
So, it's a relatively simple algorithm, but it can be incredibly powerful in the right hands, and it's also computationally efficient.
Right.
Which makes it a practical choice for a lot of real-world applications.
Yeah, so it's not just about, finding a solution. It's about finding one that's both effective and practical.
Exactly.
Okay.
And I think that's a key takeaway for anyone who's interested in machine learning. It's not just about memorizing formulas or mastering complex algorithms,
Right.
It's about understanding those underlying principles and how they can be applied to solve real problems.
So it sounds like we've covered a lot of ground today.
Yeah.
We've gone from cross entropy to gradient descent.
Yeah.
And how logistic regression can be used for classification.
Yeah, and hopefully our listeners now have a deeper appreciation for this really powerful and versatile algorithm.
I think so. And, if anyone's feeling a little lost, don't worry.
Yeah.
Sometimes the best way to learn is to just kind of revisit the basics, experiment, and maybe even, go back and give that theme song another listen.
Yeah, you never know. Those catchy tunes might spark some new connections for you.
Yeah, exactly. So until next time. Keep exploring, keep learning, and keep those brains engaged.
Absolutely.